Hello all, welcome to our project Pizza Price Prediction with AutoML and Machine Learning. So the main aim of this project is to predict the price of a pizza based on different parameters like what are the number of toppings, what is the diameter of the pizza, etc. using the automated machine learning techniques and the different machine learning techniques. So this is basically a fun project which will help you increase your machine learning skills. So what is the motivation behind this? Okay, so these type of problems you don't really find these type of problems in the real world scenario, because these are basically the problems in which these problems you can use to improve your machine learning skills. Also, if you want to flaunt your machine learning skills to your friends, you can build such applications. See, imagine if you could predict the price of the pizza on telling the on different parameters, and you don't have to look at the price board. Okay, so you can predict normally, you can flaunt your skills, you can use this machine learning skills to build these projects. It will help you improve your machine learning and auto machine learning skills. In this project we'll be seeing how to do all of these things, basically how to use automated machine learning, and that is the EVALML. So understanding the problem statement, in this we are given a data set in which various attributes are given which are used in making of a pizza, right? Like I told you earlier, the whether the pizza has tomatoes, if it has extra cheese, what are the number of toppings, what is the diameter of the pizza. These all are the important and the crucial parameters which are required for the pricing of a pizza. Then we'll use this data to build a model using machine learning techniques and automated machine learning techniques. So now when I talk about automated ML, what is AutoML? Automated machine learning is the process of automating the task of applying machine learning to real world problems. So now basically in simple words, what you can say is, if you are a domain expertise and you have all the knowledge of your domain, you can do all the feature engineering part and all other things on your own. Now if you don't know the knowledge of machine learning, like you don't know the maths behind the model, you don't know how this model works, which model will fit your data well, so you can use automated machine learning. Automated machine learning will check your according to your data and check all the models and will see, okay, which model fits my data best, then I'll use this model. So this is a very good thing, and this is why automated machine learning is used by many of the people. We'll be using the EVALMLauto library for this project. Let us have a brief introduction about the EVALML library. What is EVALML? EVALML basically is an open source automated machine learning library written in Python that automates a large part of the machine learning process, and we can easily evaluate which machine learning pipeline works better for the given set of data. So in simple words, EVALML they have all the libraries, all the classification libraries, regression libraries, clustering libraries, which comes under the scikit-learn and all the regression problems. So these the or EVALML has it all. What EVALML does is it automatically checks your data and fits all the models and see, okay, it has a attribute called compare models which I'll be showing you in the further project, and I'll be showing you how we can use EVALML and all the different things. It has a website also. You can check the official website of EVALML, from where you can obtain various different information and commands which you can use. So we'll be discussing all of these in our upcoming in this project. What is the timeline? The timeline of the project will be of something like this. First we'll be doing the data analysis, we'll be finding out relations, we'll be seeing how our data is distributed. Then we'll be doing the feature engineering, in which we'll be doing different practices like one hot encoding, label encoding, standardizing our data, like preparing our data for feeding into a machine learning model. Then we'll be building machine learning models, different ML models like the XGBoost regression, CAT boost, logistic regression, linear regression, all of the different models. I hope you know all of them. Then we'll be shifting to EVALML, that is the automated machine learning. We'll be building that model and we'll be seeing that how we can replace all of these things with the automated machine learning. So let's begin. Hello all, welcome to a project Pizza Price Prediction using machine learning algorithms and AutoML. So as discussed in the previous section, in the introduction section, I have told you that, okay, what is our data and what is our aim in this project. So now this is a context. Basically I have taken this data from the Kaggle website. You can take various data sets from the Kaggle website and practice. So it was written that the data set given is for predicting the prices of pizza. The data set is not yet complete at all, but you can use this data set for learning or study. Maybe you want to update the data by yourself. Okay, these were the disclaimer or the introduction part written by the user who uploaded the data. Okay, so now what we'll be doing in this project, we'll be building a model which will predict the prices of data pizza based on different parameters such as number of toppings, diameter, as discussed earlier. So we'll be using different machine learning models. Then we'll see how we can do all of these things with the help of auto machine learning. In that we'll be using the EVALML library. So let us discuss about the timeline of the project. The first will be importing libraries, datasets, then we'll be doing some data analysis and moving on, then we'll be doing feature engineering part, then we'll build our models using machine learning models, then we'll be building using auto ML models. Though, so let's get started. The very first thing we have to do is we have to import our libraries. We'll be importing pandas, numpy, seaborn, matplotlib. These are all for data analysis and visualization. Then we'll be doing importing label encoder for encoding one hot encoding. I'll be telling you what one hot encoding is and how we can do that with label encoder. Then we'll be importing train test split from sklearn model selection. This basically to split our data. Then I have written a line called matplotlib inline. This is basically a magic line which makes sure that okay, the whatever plot we plot, it remains in this notebook only, it opens in this notebook only. We don't have to make another window to open that. So first of all, the very first thing is we have to read a dataset. Okay, so now as we are using a Google Colab environment, so there's another procedure to import a data. What you have to do? First, you have to select your Google Drive and you have to import your CSV file in that. Okay, you just import your file in that in your drive. Then what you will do? You'll just go here. Then you'll say you are seeing this option. You'll just click on this. This is a Mount Drive option, and this appears. Okay, this appeared. I'll just execute it. Now it is giving me a link. Basically this link is used to verify my account, give permission to Google Colab to access my account. I'm giving this permission so that Google Colab can access. I'll just sign in, then it will provide me a link. I'll copy it. I'll just simply paste it here and press enter. It will take a few seconds, then it will say okay, drive mounted. As you can see, it is saying mounted at content drive. Now when I'll go here, when I'll see this is my drive is mounted, then I'll go to my drive. Then this is all the data which is present in my drive. Okay, so now what I have to do, I want my file to get uploaded here. I've already uploaded my CSV file in my drive. I'll just copy the path, copy path. Pizza v2 is my CSV file. I'll just paste it here. I'll paste the path here. Okay, this is my path. I'll just read it and store it under my data frame named df. If I want to see what is my data frame, then I'll see. Okay, so let us understand a bit about this data. As I've said that we have to predict this price. Okay, we have to predict this price. So in that there are various parameters given, that is the diameter of the pizza, then toppings, that what is the topping of the pizza, that how many different toppings are there and which pizza has which toppings. Then we'll see what is the variant of the pizza size, whether what is the size, it is a regular, it is a jumbo, or it is a small, if the pizza is extra sauce in it, if it has extra cheese in it and extra mushrooms. Also this has different companies. Okay, there are 4 companies. If I tell you df.tail, see there are 5 companies A, B, C, D and E. We'll be seeing how these different companies are distributed and all of these things in my data analysis part. So this was all about how to import our libraries and how to import our data set. In the next section we'll be seeing the data analysis part and feature engineering part, and if in the further section we'll see how we can build our models using machine learning and auto machine learning. Hello all, welcome to our next section of the project, that is the data analysis part. In this we'll be seeing our data, we'll be analyzing it and we'll be visualizing different things. So first let us have a look at our data. So this is our data from the previous sections which we imported. We have different companies, we have the independent variable price, we have diameter, different toppings, variants, size, if the pizza has extra sauce, cheese or mushrooms. So we'll just name this section as data analysis. Now let us see if this data has some null values or not, right? So as you can see, this has no null values, which is a good thing because we don't have to do much. We don't have to worry about null values now. So then we'll just view the data info, that okay, what are the data types? Okay, every of the data type is here object, right? So we have to convert this into in integer or float in order to do some processing. We'll be doing that. So let us see what are different columns. We know them already. These are the different columns. So now in order to, for our ease, we just rename some of the columns. Like in the price rupiah, we have no need of this rupiah, right? So we'll just rename it, okay, df dot rename price rupiah to price in place true. Then what I'll do, as you can see in the price, this is an unnecessary column which is rp. Okay, I don't want it, I have no significance of it. I'll just remove it and replace it with a space bar. How I am doing that, df dot price dot string replace, because that is a string, okay, dot replace with another string, which is a space bar. So and lastly I am telling it, okay, convert that into an int, because that is an int already, right? This is an int, so I want that is at an int. In the same, in the diameter part, the inch is unnecessary, okay, so I'll also remove that. I'll say df diameter dot string dot extract. I wanted I'm saying that, okay, extract only the working part, okay, only the numerical part, okay, I am saying, and leave all of that, and I'm saying convert that into float. So I have done all of these things. Then I'll just see my data. When I'll see that, okay, my diameter is converted into float, if I would have typed the int, then it would have only been 22, but I've typed there as float. That is why it is 22.0. Then I've removed all the other things which were present in diameter, just the inch, and I've removed the rupiah with rp, and price rupiah is also changed to price. Okay, so now one second. So now what happens is, what we have to do, we'll just be doing the another data analysis part, okay, how we can visualize our data. So what I am doing here, that we have different companies, right? So first we'll be seeing that how our data is distributed based on the different parameters, right? I am doing, I am plotting a pie chart. I am plotting a pie chart. You'll see I am plotting a pie chart which is telling me, okay, which attribute is having what weightage. The first pie chart let's see what is the command used in it. This is very simple. I plotted a figure, then I said, okay, plot dot pie. I am giving him the attribute df dot company dot value counts. So value counts means that it will give me all the value of each category that attribute is having, right? And pie chart will automatically convert it into percentage. Then this is some visualization practice, and this is the labels, okay. Or what are the labels? I am just telling me, okay, the what are the different value counts, unique values, okay, provide me those labels. It will match it, and it will just say I'm giving the title of the pie chart. Just similarly with all of the variables, I have done the same. For diameter also I am giving and the value counts, for toppings, for variants, for size, extra sauce, extra cheese. So when we'll see that, okay, there are 5 companies and each have around equal number of weightage. The highest is around A and B, 23.3 weightage. Then the least is about D. Oh, least is about E, okay, 15.5 weightage. And the diameter when see, then okay, we are seeing that 22-inch diameter is the largest, okay, it is in the majority, followed by 20 and 16, and rest of all are the little diameter which are having very less weightage. Then we'll see toppings. So when see that the chicken topping is maximum, followed by pepperoni, mushroom and smoked beef, then rest of all are very less in number. The least is the beef, okay. So now when if we'll see about what, this is basically the basically the category, okay, this is basically the category. So as you can see, it is the maximum number is around double signature, rest of all are distributed normally, like many of the distributed in 2 to 3 3 4 4%, right? Some of them are American favorite, super supreme, meat lover. These are all are quite large in number comparable to these. Then if we'll see about the size, then most of the pizza is jumbo size, and then the regular, small and medium are equally distributed. XL is the least preferred by the customers. Then we'll see extra sauce, as we see that more than 50%, around 60% of customers has taken extra sauce. and extra cheese is also the same, around 66% have taken extra cheese. So this was a brief show that okay, how our attributes are distributed and what our customers prefer. So then what we'll see that we have we'll plot a histogram plot in the company variable, right? Okay, what we did, we are taking u as extra sauce. What I am doing that, I am taking okay, tell me which country, which company is distributed how, and which, in which company what person has taken extra sauce or not. Hue is a parameter which distinguish it. I am saying okay, tell me the count of the customers of the country company. I am saying that okay, c, we'll use also see the same in the pie chart also, the c will have the highest weightage. Okay, so this is the histogram on the plot of C. Then we'll be saying that the company E, the maximum number of people have taken the extra sauce, yes, okay, and the rest have not. Okay, sorry, I told the opposite. In the company C, maximum number of people have taken the extra sauce, yes. Okay, so similarly, what I am doing, I am also seeing for the company part. Okay, I am saying that okay, group by group by my company on the basis of this count, and I'm then plotting a KD plot, KD distribution plot. Okay, saying that okay, which company is having the largest, which company is having the largest value counts. Okay, so this is how my it is distributed. Then I'll do the same for toppings. As you can see, this is how my toppings value are distributed on the base of my counts. Okay, on the base of my counts. Then what I'll see that I'll plot a histogram plot on the same what I did for the same what I did for extra sauce. I'm doing the same for extra cheese. Okay, also see, I'm seeing that which company in where users use the maximum number of extra cheese or opted for extra cheese. Then I'll do the same for extra sauce. Okay, then I'll see that okay, how my price is distributed. Then I'll see okay, the when you'll see that okay, my maximum number of price is distributed around 10, this column. Okay, this column my maximum price is distributed, which has the largest. This has the largest. Okay, so now what we found out from these data was that it okay, which company people preferred the extra sauce mechanism, and which were required the highest price, and how my price was distributed. Then in the same in the next section, what I am doing, I am just plotting a point plot, seeing that okay, I'm plotting my point plot seeing on the basis of my diameter. Okay, which diameter pizza is having the highest price. From that I can interpret that the pizza between the 18 to 18.5 diameter range is having the highest price. You can see that okay, the price is very high, and the pizza with 8.5 diameter to 8 is having the least price. Okay, so the same thing I can do with the variant also, that how my variant is distributed. Okay, these are all my variants. Then I'm seeing that the double signature pizza is the costliest. Okay, the double signature, and rest and followed by the double mix. Rest all are approximately same, from spicy tuna to this. Okay, many of the all of our same, or all fall in the same value, except for, and then the American favorite, super supreme, meat lover, these are all fall in the same value. So from this we interpret this, these are all the low range pizza, these are all the mid range pizza, and this is the high range pizza, that is the double signature, as you can find out from the name only. Then what I'll do the same for toppings. We'll see what all different toppings are there and which toppings is the most expensive one. Then when I see that pepperoni toppings is the most expensive one, right? Then rest of all are quite same. The many of rest of all toppings are having the same value. Some of the outliers are there, but rest of all are same. So this was some data analysis on our data. Actually, this we don't have much to do data analysis in this data, because this is a very simple data with no null values and a very small data. This is basically for your practice and to practice your data visualization and ML techniques. So in the next section, we'll be doing the feature engineering. In that, we'll be converting our data. We'll be doing the label encoding, and we'll be seeing okay, how we can prepare our data for our model, for feeding our model. Hello, welcome to our next section of this project, that is the feature engineering. Now in this project, in this section, we'll be doing the feature engineering, in which we'll be doing the techniques such as one-hot encoding and the different techniques, so that we can make our model feedable. So why we are doing this one-hot encoding, right? when you can see in your data, there are various attributes like size, extra sauce, extra cheese, extra mushroom, company. These are all present in categories, right? And these are present in text format. Our model cannot understand it. Okay, our model cannot understand the same. So what we will do, we'll just convert these, or we'll just assign them some labels. We'll just assign them some labels. We can do two things. Okay, either we can assign them labels directly, like I can assign jumbo for one, regular for two. I can assign these labels. So I can assign company A1, B2, and the same. Okay, this is known as label encoding. But we can do some another thing which is known as one hot encoding. So what one hot encoding is, I'll just show you in a minute when I'll just execute this command. So I'm just defining two function. I'm saying one hot encoding. I'm saying that okay, I'm taking my df and I'm taking my column. I'm saying okay, do one hot encoding. Okay, this is one hot encoder. I'll little just perform the one hot encoding into my data set. I'm just I'm just again providing my column. I'm just again defining my another function which is taking my column and converting it into a one hot encoding. So now what this will do, I'll just show you what this will do. When I'll see my data, when I'll see my data set. Okay, so now what happens is, what it do that, as you can see, various number of labels are created. So as I have said earlier, there were two things, right? One was label encoding, in which I would have easily assigned each label for each my toppings. As you can see, I would have assigned pepperoni for one, mushroom for two, in a single column. In a single column, all of my labels were assigned. But instead of that, in order to make my model more accurate, I performed one hot encoding. So one hot encoding, what it did, it created that many number of columns, that how many categories were there, like how many toppings were there. Let's suppose company, there were five companies, so it created five different columns, and wherever the value for that company was yes, it created a one for that and zero for others. For example, my first data was from company one, right? So there is a one in company one, and rest of it is zero. Similarly, it happened for all of them, and similarly for toppings. In my first data, the topping is chicken. Okay, that's why the one is in chicken section and rest of all is zero. In the second, the topping is pepperoni. That's why the one is in pepperoni and rest of all is zero. Okay, similarly all my toppings are there, then all my different categories or my different types of pizza, the double signature, American favorite, all my one dummies are created. These are called dummies, right? These are different dummies in which my various data is feeded. Okay, so this X for extra sauce, no extra sauce, yes. Okay, so as you can see, every other things, every dummies are created. So now what I did it one hot encoding. How I did this, I simply defined a function. In that, I imported a library known as category encoders. This basically fitted my category. This basically does one hot encoding for now. If you get one of the error like cannot import category encoder, if you will be performing it in a Google Colab environment, you can just install it, you can just upgrade it using it and restart your runtime. Okay, if you will not restart your runtime, it will again show that error. If you will restart your runtime, it will read the library, then your error will not be shown. I just simply write a function to do the one hot encoding. This is a very simple one line code. In that, I am just giving my data, and it will be performing the one hot encoding for all of these. Now the only thing left is, okay, these are all my data frames. Okay, as you can see, this all int 64. All of this are converted into my 64 except my diameter, which is a float, which I only converted. Okay, so these are all my different category columns which are created. So may take in mind, there I did one hot encoding here because there were not more than 10 categories. Okay, if there would have many number of categories, I cannot perform one hot encoding because too many number of columns will be created. Suppose if there are 25 categories in a column, okay, so 25 new columns will be created, which can lead to curse of dimensionality. Many number of columns will be created, which will eventually make the model perform underperform. Okay, so make sure in keep that in mind when to use one hot encoding, when to use label encoder. Okay, so now what we can do, we'll just split our data into dependent and independent variables. These are my independent variables, and price is my, as usual, dependent variables. I have converted into my x and y, then I'll just complete convert into my x train and y train data. If I want to see my x train data, this is my x train data. Okay, so these are all my x train data. Okay, x train data. If I want to see the shape of it, if I want to see okay how my it is distributed, what is the shape of it, this is 103 by 50, 103 rows and 50 columns. As you can see, 50 columns are created, right, based on that. Okay, so now if I want to see x test shape, okay, see 26, because I use the size 20% for test and 80% for train data. Okay, so now I have completely created my data, I have featured it, I have done the data analysis part, and my data is ready to fit into the model. Okay, so now what I'll do, I'll just simply feed my data into my model, which will be doing in the next section. Hello all, welcome to our next section of the project. In this section, we'll be building our models using the machine learning algorithms. The algorithms we'll be using here are the XGBoost regressor and the support vector regressor. So now, moving on to our first algorithm, that is the XGBoost regressor. You might all have heard about what XGBoost regressor is. It is basically an ensemble technique which is the gradient boosting, extreme gradient boosting regressor. Now what happens in this, many number of, it is an ensemble technique, so many number of models are created inside it, and it has a particular mechanism of how XGBoost regressor works. You can have a look at the documentation of XGB and to see that how boosting techniques actually work. So now what we'll do, we'll just import the XGB regressor. Now for some reason, if the XGBoost is not imported in your machine, you can first have to install it. You can see how you can install the XGBoost regressor in your library, but it should get imported with no problem. Now the next thing what I am doing is I am using a grid search CV to find out what is the best parameter for my model. So now basically there are two things. There is grid search CV and the another one is randomized search CV. Now there is a many minute difference between them. In grid search CV, what happens is it searches the data on the basis of grid. It has a predefined way of taking the data and it will take on that manner. But what happens in a randomized search CV, it randomly takes the data in various number of folds, and you don't know okay, which data is getting created. Moreover, grid search CV and randomized search CV both can be used, but grid randomized search CV is not suitable for a variable for a when you have a large amount of data, because it will create many number of variables which will take a lot of time. So people usually prefer grid search CV. You can use both of them to see okay which data performs better. It simply does what it does it in grid search CV. We provide certain parameters. What grid search CV will do, it will search for all, it will fit our model for all those parameters, and will search that okay which model is fitting the which parameters are fitting the best. For example, from net I have taken these estimators. I have taken number of estimators 2000, 4000, 6000, max, step 3, 4, 5, 6, and different learning rates. I have simply taken these from the net to see okay what are the most favorable parameters for a XGB regressor. I have just stored them in a dictionary. Then what I'll do, okay, first I have to import this. Then what I'll do, I'll just create or define my grid search CV model. I am saying that okay, define a model in a grid search CV. Put the model is as XGB regressor. Put a random state 42. You can put any random state. Then I say okay, take a random parameter grid is equals to param grid, which I have stored, and scoring is r square. Which means that okay, define or take my model on the base of r square, which is having the highest r square. Give me those parameters. So I have just simply defined my model. If I want to see my X train head, this is my X train data. Okay, this is my train data. Now what I have to do, I have to simply fit this model. So I am not fitting this model currently because it took me around 20 to 25 minutes to get this model fitted because of the time. The main thing is grid search CV takes a lot of time. Okay, it took a huge amount of time for me to get this model fitted. You can try on your own, see what are the best parameters by just writing final, which is the model I defined, final dot best parameters. I'll just simply use that and I got these parameters, right? I got these parameters. Learning rate is 0.2, max depth 6, and number of estimators is 2000. I got these parameters. I just simply fit my model based on these. Okay, I defined my model based on these parameters. I'll just fit it and I'll predict. Okay, my model is fitted with these parameters. I have predicted my stored them in a variable called predict. Then if to check accuracy, I'll import metrics and I can see my mean absolute error, mean squared error, and my R square. As you can see, my R square is around 81%, which is a quite good score. My mean absolute error, this RMSE is this. So this is how you can check the accuracy, and as you see that our model is performed quite good. Now the next model which I'll be using is support vector regressor. Okay, the SVM machines, right? SVM machine, you must have all familiar. In this I have not done much. I have simply fitted my model. I have just imported the SVR model, the support vector from sklearn.svm support vector machine import a support vector regressor. Okay, I just fitted my model and I have seen, okay, what is my score accuracy. Okay, this is my score accuracy. This is my MA and RMSE. Like this, you can do many number of models, right? These are only two models which I have seen. So because in the next section we'll be seeing how we can use the auto ML. If you want to use one more model, we can take an example of linear regression, linear, and we will see how it performs. I'll just import my linear regression model. I'll define it. I'll just say lean reg is equals to linear linear regression. I have defined my model. Then I'll say line reg dot fit. I am fitting my model with the data x train, y train. I am just predicting my data. Line reg dot predict with x test. Then we'll see. It is getting fitted. Okay, it is saying line reg is not defined. Okay, sorry, I did. Now it will work fine. So as you see, it is done the prediction. Then we'll see the same accuracies. Then see how our model is performed in this. Then we'll just change the prediction one to predict two. Again in the prediction one to predict two. So as you can see, my linear regression model also performed quite good with an R square of 86%, right? This is an MA and RMSE. So like this, you can perform this operation on various models. I have not done much hyper tuning in it, but you can do the various hyper tuning by using the grid search CV or randomized search CV. You can perform various models. You can use ensemble techniques in your model. You can combine two models. There are numerous amounts of things which you can do, but this you have to do by writing code on your own, right? So now in the next section we'll see that how we can automate these things. Okay, we'll be using the EVALML to automate all of these model building and hyper tuning techniques, and we'll see how to do that in the next section. Hello all, welcome to our final section of the project, that is the usage of auto machine learning. So now, as discussed in the previous sections, we have seen that how we can do the data analysis of a particular data set, how we do feature engineering, and how we prepare our data for our model. Then we have seen that how we can apply or define many machine learning models and hyper tune them. Now what we'll do, we'll see that how we can automate all the model building process with the help of automated machine learning. As discussed earlier, automated machine learning automates a huge amount of process which a data scientist do in the form of model building and hyper tuning and evaluation, and does all of these things in a single lines of code. So now AutoML is basically used by the people who are having the domain knowledge but do not have much knowledge about the machine learning or the data science. These people use AutoML to make their work easier. Or data scientists often sometimes use AutoML to make their work easier and do all of these things. So now we'll be using EVALML library. Let us have a brief introduction about EVALML. EVALML is an open source AutoML library written in Python that automates a large part of machine learning process, and we can easily evaluate which machine learning pipeline works better for the given set of data. What EVALML does, it will evaluate all the models based on your data. It will tell you okay which model performs better, and it will give you that pipeline. Okay, this is how cool the EVALML is. So now on proceeding it, what you have to do, you have to first install EVALML. You can directly install EVALML if you are working on a Jupyter environment or a Google Colab environment, and if you want to install EVALML in your library only, in your notebook only, you can just write the command pip install evalml with an exclamation mark. Or if you want to install evalml in your system directly from the command prompt, you can simply write pip install evalml in your command prompt. It will automatically get installed. Now what, as you can see, it is installing all the libraries. It is downloading xgboost, downloading sktime, downloading klido, and all they're downloading feature tools, downloading imbalanced learn. This is for the imbalanced data set, and all of these things. Many of the downloading cat boost. All of these things are performed under evalml library. Okay, so this is quite good, and as some of the requirements are already satisfied, that is it, that's why it is saying requirement already satisfied. As you can see, it is downloading and then storing my library in this. It will take a few more time. It will take a few more seconds, or 1 or 2 minutes to get installed. It is generally depends upon your internet connection, right? How fast your internet connection is, and how fast the processing power of your computer is. So now, as you can see, it must be getting finished in some part. It is getting in. It is what now right now it is doing. It is uninstalling the installed library which you present earlier, right? Okay, the previous model which we have present, it is installing those, and it is installing the updated version of those library. As you can see, all of these things are executed. By that time it gets installed, we can see what all the further things we have to do. Then what, in this we are using the same train and test data set, right? Because the same train and test, remember, we have done some feature engineering in your data set. It is often said that AutoML also perform, it is often said that AutoML also perform the feature engineering things, but according to me, the feature engineering is best performed by a person who is having the domain knowledge. Okay, he can successfully add or remove features because he know what is the importance. So the feature engineering part must be done by the person itself only. One should evaluate AutoML for using AutoML only for model building and evaluation part. So now, as you can see, it has done all the things, and it is saying restart runtime. But I have already installed the EVALML. So okay, it is saying not found. I'll just restart the runtime. The restart runtime is necessary because whenever these libraries are installed, right? So these libraries are installed. So when Google Colab environment only read those libraries when you restart your runtime. Unless and until Google Colab will not read those libraries. Now, as you'll see, it will automatically import EVALML with no problem. Okay, as you can see, evalml is imported. So now what I have to do, I'll see that what are the different problem types I can solve with evalml. This is something called binary. If I want to select that, this is the classification part. It is 0 or 1, like churn prediction, or it is the disease heart disease prediction. That is a binary. If it's multi-class, various number of class, I have to predict basically clustering. Then our problem is regression problem, right? We have to predict the price. Time series regression means which keeps changing with time, like the stock market data prediction, petrol price prediction. Similar with the time series binary and time series multi-class. Okay, so we'll be using the same featured data set. As I have restarted my runtime, I again have to import all of my data. I'll just simply import my data again. I'll just do the all the things which I have did earlier. I'll just execute them. It will take a minute. Because of the restarting the runtime, all of the things were done. Okay, all of the things were restarted, so I have to do all of these things from once again. That's why I'm doing all of these things. Okay, now I have again created my X train and Y train. I'll use this data for my EVALML. So now what I am doing, that I am saying okay, split my data and the problem type is regression. I have to specify my problem type in evalml dot pre-processing. What, even though I have pre-processed my data, if I would have directly given my data, it would have pre-processed my data like the one hot encoding, and if the scaling is required, it would have done that for the model. But I've already done it, so it would not have been required for this. It is just splitting my data into training test data. I'm saying okay, problem type is regression. I have to specify that. Okay, evalml.processing.split data. Now what I'll do, I'll import a command from evalml.oml, import automl search. What automl search will do, it will basically run for all the commands. It will basically run for all the commands and see okay which is my best pipeline, and which is suiting my parameter best. Okay, when you will see it, it will run through all the models. Okay, all the models which comes in the regression part, and it will see now what I'll do, as you can see it is automatically searched. Then I can say auto ml dot rankings. Okay, now as you can see it is telling me all the models which have performed the best. As you can see, extra tree regressor with log transfer performs the best with a mean CV square of 86.6%. Okay, validation square of 90%. Okay, so now based on all of these things, by this based on mean CV square, it is saying me that extra tree regressor is the best. I can also see okay what is the pipeline involved, what were the different hyperparameters used. As you can see, extra tree regressor is used, imputer, what was the imputer used, and what are the other things were used. I am storing this into a best pipeline variable. Then I am describing my model, right? It will describe it in a more vast manner. It will describe it in a more vast manner. As you can see, all the R square is given. The 90.3% is my R square. This is my variance, maximum error, median, MSE, RMSE, all of these things. Okay, and it is also giving me my R square, the mean R square. What is my mean R square? The objective means the accuracy metric. There are different objectives in EVALML. You can select any of those. Then if I want to see that okay, if I am telling that okay, train my model based on a R square objective. Okay, give me the model which is having a highest R square. It can be instructed you by your instructor. Okay, give my R square would be AOC, my R square would be RMSE, or it would be R square. I'm taking a R square. You can also give price secondary objectives, like they can, you can search, it will give the ranking to the model according to that. But here I am taking only R square method. It will again search all those models. Okay, it will again search all those models and give me those models which performs the best according to my R square category. Then I'll do the same. I'll just take the rankings, and I'll do the same what I did to them, that I'll just describe my model, the best performing model. As you can see here also, the same model comes here is extra tree regressor only. What I'll do, I'll just okay, let me cut this slide. Okay, then I'll just take my best pipeline. Okay, which is my best pipeline? I'll say best pipeline dot R square, R squares. I have to store my best pipeline, right? I have to first store it. So I'll use the same automl dot best pipeline. I'll write a code here. Best pipeline is equals to automl dot dot best pipeline. Okay, as you can see it is fitted. Now it will just give me the score. Best pipeline R, oh sorry, okay, this is my R square. So now as you can see, I have taken my model on the base of R square also. Now what I can do, I can save my model. I'll just simply save my model in a pickle file. If you want, you can do that. I'll just load our model in the form of pickle, or you can directly load your model. Then I'll just predict what are the predictions on my test data. So these are all my prices of the pizza. Okay, this is my test data. These are all my prices. So as you can see, this was a brief introduction of how you can use EVALML in the pizza price prediction. I have already made one project more, that is the heart disease prediction using EVALML. This was also another project. So this is something what you can do based on this project, and also different project. You can try different things. All the notebooks are provided to you, and you can visit the EVALML website, and you can see, okay, what are the different commands in it, what all things you can do more. You can also hyper tune your model. You can deploy your model with the help of EVALML. There are numerous amount of things with to do in AutoML, that is the EVALML library.